We present automating deformable gasket assembly. In gasket assembly, we align a deformable gasket with a narrow channel and press the gasket into the channel such that it makes a snug, secure fit. This task is a long horizon, high precision task. We present three channels: an open straight channel, an open curved channel, and a closed trapezoidal channel. We also use a white 0.5-inch braided nylon rope as our gasket analog. Here we show the gasket fully inserted in each of the channels. We present four methods: learned diffusion policy and three procedural algorithms: unidirectional, binary search, and a hybrid of both. Here we see the learned diffusion policy successfully carrying out the task on the straight channel. Here we see the learned diffusion policy failing at carrying out the task on the straight channel. Here we see the unidirectional algorithm successfully carrying out the task on the straight channel. Here we see the unidirectional algorithm failing to carry out the task on the straight channel. We evaluate the method's performance in two components: alignment and insertion. A human judge assigns the performance into one of four equal buckets. Our results suggest that deep imitation learning can fail lowest quartile of performance on a straight channel in 2 of 10 trials, whereas a hybrid procedural algorithm achieves highest quartile performance in all 10 trials. The procedural algorithms also perform reliably on the curved channel, but poorly on the closed trapezoidal channel. We present automating deformable gasket assembly. Please see our website for more content and videos. Thank you.